first I want to go over your guided reading to kind of make sure that you understood the concepts that you read, and then we're going to do some stuff with valence electrons and kind of put some things together. And we'll be working on that the rest of this week. Okay? So the periodic table organizes the chemical elements. So each one of these is an element, and it's organized by increasing atomic number, which was the last chapter. Okay? Each block on the periodic table describes basic properties of one element. So when they talk about one block, they're talking about the square that we talked about, the element key, and what it all tells us. Within the element key, we know whether it's a metal, non-metal, metalloid. We know whether it's solid, liquid, or gas at room temperature. We know its atomic number. We know its mass. We know the element. We know the symbol. So each one has all that information on the periodic table, okay, for each element. The periodic table lists elements in order by atomic number. Elements, I'm on number 4, A4. Elements in each period have similar physical properties. We've talked about that. Period is about physical properties. They both start with P, okay? Metals are on the left side of the periodic table, then your non-metals, and then to the far right are your non-metals, and then down the stair step, the divide between metals and non-metals are metalloids, because they share properties of both types. Okay? B, new material. Most of the matter around you is made up of compounds. So they include 2 or more different elements bonded together. A chemical bond is a force that holds them together. Atoms contain protons with a positive charge, neutrons with a neutral charge, and electrons with a negative charge. This is all that you already know that. Electrons are the atomic particles that participate in chemical bonding. That is new. Electrons, specifically the valence electrons, are the ones that determine who will bond with who or not bond at all. Okay? The amount of energy an electron can have is an energy level. That's related to the period, and I'm going to show you that in just a moment. Electrons closest to the nucleus have the least amount of energy, and electrons furthest away from the nucleus have the most amount of energy. They have to travel further. They have to go, the ones closer to the nucleus just travel a little bit. And then the ones furthest away, they're traveling a lot. Okay, they've got a lot of space to cover. All right, the maximum number of electrons in the first energy level, which is closest to the nucleus, is 2. Because it's such a small area, they would collide with each other if there were more than 2. So only 2 can fit on that energy level. And you'll see how many elements are in the first period. 2. Coincidence? No. All right. In the second energy level, the most they can do is 8. So there's actually a formula for that, which 8th graders don't have to know that formula, but I'll show it to you. The valence electrons in an atom are involved in the chemical bonding. These electrons are less strongly attached to the nucleus because they're the furthest. Valence electrons, the definition is the electrons that are in the outermost energy level. Outermost. So they're furthest away from the nucleus. That means they have the least amount of energy. That means they can have a little more freedom to move to another atom or to share with another atom, okay? But the ones closest to the nucleus, that's a little trickier. It's a little trickier. They have more energy, so they're less likely to move away. So a valence electron is an outermost, I'm on number 4, outermost electron that participates in chemical bonding. 4A, the number of valence electrons in an atom tells you how many bonds an atom can form. B, each element in the same group in the periodic table has the same number of valence electrons. I'm going to talk you through how to relate the group number to the number of valence electrons. Okay? It's really easy. Number 5. The electron dot diagram is a model that represents valence electrons. We'll be doing dot diagram races. 5A, to create an electron dot diagram, draw one dot for each electron in the atom, placing one dot on each of the four sides of the symbol, and then pairing additional dots. The number of unpaired dots in the electron dot diagram tells you how many bonds an atom can form. So the goal is for each valence electron to have a partner. They want to pair up. Okay? Many atoms are stable with 8 valence electrons, so that means 4 pairs. An atom with at least one unpaired electron is chemically unstable because it wants everybody to have 8. Except for period 1, energy level 1, it can only have 2. Okay? Stable atoms do not easily react with or form bonds with other atoms. Group 18 includes the noble gases, with the exception of helium. Each of these gases has 8 valence electrons. C, unstable atoms can become stable only by forming bonds. That's how they get stable. That's how they get the 8. And the rule that is, the chemistry rule that is, it's called the octet rule. The octet rule, 8 valence electrons, octet. D, atoms tend to gain, lose, or share valence electrons until each atom has the same number of valence electrons as the noble gases. 8. Octet. And then stable atoms have 4 pairs of valence electrons. So that's your guided reading, or your notes, depending on which way you went about it. Okay? So let's relate it to the periodic table. Looks like you might not be able to see all the way over to group 18. Remember early on, we looked at, these are the group numbers, 1, 2, 3, 4, 5, 6, 7, they're right there, okay? We skipped the transitions for this activity or this way of understanding chemical bonds because they kind of have their own little rules. Some of them actually have more than one type of electron configuration. So we skip those because, you know, just like the English language, there's always exceptions to the rules. These guys have slight exceptions to the rules. So I don't do those to you. I only do the ones that follow the rules so that you can do this correctly.